So in today's video, I will be trying to study about SIMD operations, single instruction, multiple data, whatever the hell that is. I have a little bit of experience in this while working on previous projects, but a lot of it was done with the help of LLMs. I did not understand what I was doing, what I was trying to load from the memory, what I was trying to write back to the memory, a lot of that stuff. So I found this PDF, uh, optimizing software in C++, by Agner, and there is a part there called using vector operations, and I will be trying to finish that today. So we will read through it one by one, and then whatever the examples are present here, we will try to finish them. How big is it? Quite extensive. Holy moly. So it is quite big, as you can say, like 15-20 pages, but we will go through it. We'll try to. Let's start reading it one by one. There's not some sort of a video where I'll try to teach you anything that I've learned. No, this is a video where I'll be learning it myself. So microprocessors have vector instructions that make it possible to do operations on, okay, that I know about. This is called single instruction multiple data. Size of the vector can be 64 bits, called MMX, 128 bits, XMM set, and 256 and 512 bits. So these are, I guess, different instruction sets. So let me just check it here. What are MMX and XMM and YMM? Are these some instruction sets for different processes or architectures? They are not instruction set themselves, they are register families used by SIMD. So uh, these are vector registers, whereas SSE, AVX, and AVX 512 are instruction sets. Instruction sets operate on these registers. So these are registers and memory close to CPU. What happened? Registers inside the CPU, not memories. Yeah, I mean by memory, I guess it is saying RAM. Inside CPU, we have L1 and 2, L3 registers. RAM is outside the CPU and disk is very far away. A lot of pigeons outside my window. What exactly is a register? Is a fixed storage cell directly rewritten by CPU instructions, accessed in one CPU cycle or less. No RAM cache address, pure CPU internals. Where do these registers physically live? Inside the core. Memory, like they're large, up to 512 bits. We have seen that. We can load and store them. But loading and storing is not equal to memory. After loading, everything happens inside the registers. Location, access, speed, shared. Fine. Move on. Vector operations are useful when doing calculations on large data set where the same operation, okay, algorithms that are serial. The vector operations use a set of special vector registers. The maximum size of each register is 128 if it is a SSE2 instruction set. 256 if the AVX instruction set is available. 512 if it is AVX 512. Number of elements in each vector depend on the size and type of data. So let's look at some examples. We have correct char or char or character, whatever you want to say it. Size is 8-bit, which is 1 byte. Number of elements 8 if the size of the vector is 64-bit. So if 64, 8 times 8 is 64, instruction set is MMX. In SSE2, where it is 128, we can store 16 of them. In AVX2, 32 of them. And in 512, we can have 64 of them. Fine, looks fine, looks fine. For example, the older MMX registers, which are this white, should be avoided since they cannot be mixed with whatever the hell that means. The 128 XMM vectors must be aligned by 16, that is stored at a memory address that is divisible by 16 when compiling for an instruction set lower than AVX. Okay, let me read it again. 128-bit XMM vectors. What are XMM vectors? These are registers and they must be aligned by 16, right? Okay, so that means they should be divisible by 16. And when we are compiling them for an instruction set lower than AVX, what is lower than AVX? We have SSE2 and MMX. Okay, the 256 are preferred to be aligned by 32 and 512-bit registers by 64. But the alignment requirements are less strict when compiling for AVX and later instruction sets. So what I can feel right now is AVX is the best one. Is AVX the best one? Maybe. Vector operations are particularly fast on new processes. Many processors can calculate a vector just as fast as a scalar. Okay, the first generation support new vectors, have execution, memory ports. These units are used twice for handling a full size vector. The use of vector operations is far more advantageous than smaller the data is. For example, you get 16 float additions in the same time that it takes to do 8 addition with double. Okay, so you are saying it is more advantageous when the data type that we are using, for example, float instead of double, we can have the operations complete in almost the same time for 16 floats, whereas we can do it only for 8 doubles that same period of time. 128-bit SSM registers are extended to 256-bit named YMM in the AVX instruction set. You know what? I'm getting bored reading all this theory, so please give me the code. The main advantages of, okay, again, an advantage of AVX. What is AVX instruction set and how to check if my CPU has that? Is this a valid question to ask? Advanced vector extensions. Nice, nice, nice name. Sounds like a NASA laboratory. It's an instruction set for x86 CPUs that lets the CPU work on many numbers at once using 256-bit vector registers with fewer instructions higher throughput. Okay, what AVX actually adds. Before AVX, we only had 128-bit registers. We can only have 4 floats at a time, which is 32 times 4. With AVX, size has gone up. That is nice. 8 floats at a time, clear instruction format, few register to register limitations, example idea, not real syntax. We have AVX, AVX2, and AVX 512. In AVX, we could only do floating point. In AVX2, we have integer ops. In AVX 512, we have 512-bit operations as well. Now, most consumer CPUs have AVX and AVX2. Does AVX change the architecture? No, it is still this. I have to check if your CPU supports AVX. Um, LS CPU. AVX, AVX2, very nice, very, very, very nice. What else do we have here? What the hell is all this thing? SMC, SMC, LSCP. We have flags. CPU architecture is 64-bit. Nice, I knew that. 8 core. 8 core, right? 8 core. You can see 8 core, very old laptop, but it is working fine till now. Don't jinx it. Code that is compiled for AVX can only run if AVX is supported by CPU and the operating system. Old OS without support for AVX are really unusable. That is not a problem. That is fine, very fine. I'm not going that old. I'm not 45 years old. There's a problem when mixing code compiled with and without AVX support on some Intel processors. Intel can go eat shit. There is a performance penalty when going from AVX code to non-AVX code. This penalty should be avoided by calling. Okay, let me read again. There is a performance penalty when going from AVX to non-AVX code because the change in Y register state. The penalty should be avoided by calling the intrinsic function 256 zero upper before any transition from AVX code. What does that mean? Can you please explain the chat? Sentence is infamous, but I am seeing it for the first time. I've never heard about it. AVX uses this registers. Old SSE code only understands 128. So when you mix them, the CPU has to clean up state. The cleanup is expensive unless you help it. Okay, got it. So when AVX code runs, we have add. So I guess this is adding X and Y vectors. Writes both lower and upper bits of leaves upper 128 bit dirty. Uh, uh, Writes both lower and upper bits of this. When this is to switch to old SSC code, SSC knows nothing about this. The contains live data. If I ignore it, it might okay. Merge clean zero the upper halves. The intrinsic generates one instruction, V0 upper. V0 upper does set to 0. Leaves the lower 128 bit intact. Got it. So what I'm assuming is in AVX we had 256 bits, but SSE2 does not know about the starting 128 bit, so it has to set it 0, but we need to provide an instruction to the CPU so that it does not need to identify it by itself. So we are helping it somehow. We do this and we'll set the upper bits to 0. If part of the program is compiled with AVX support, another part of program is compiled with without AVX support, then call this before leaving the AVX part. The function is compiled in multiple ways. I have AVX. I don't give a damn about SSE2. Can we just leave it as it is? Okay. The 256-bit YMM registers are extended to 512 registers named ZMM, and this. The number of vector registers is extended from 16 to 32 and 64-bit mode. There are only 8 vector registers in 32-bit mode. Okay. It should be preferably compiled for 60-bit mode. I don't have AVX 512. Do I need to learn it? Do I need to learn all of this stuff? I don't know. I only want to know the basics. Nice. I can see some C code, or according to this book, C++ code. Good compilers can use the vector operations automatically in cases where the parallelism is obvious. Okay. See the compiler documentation for the detailed example. So we have a size, we have two arrays, and we want to just add. We have a loop and that. The good compiler will optimize this loop by using vector operations when the SSC2 or later instruction set is specified. The code will read 4, 8, or 16 elements of B into a vector register depending on the instruction and do an operation and so on, blah 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 blah. This operation will be repeated as many times as the array is divided by the number of elements per vector. So if it will read 4 and array size is 101, so it will read for 25 times, and for the last remaining one, it has to handle it separately, right? I think that is what is supposed to mean. It is best when the loop count is divisible by the number of elements per vectors. Okay, got it. You may add dummy elements at the end of the array to make the array size a multiple of vector size. The disadvantage when array are accessed through pointers. We have a function add two. We have two pointer a and bb. We are trying to do the same thing as earlier. The performance is best if the arrays are aligned by vector size. Okay, efficient vector operations under instruction sets prior to AVX require the arrays to be aligned by addresses divisible by 16. The compiler can align the array as required, but an example this, where are the examples? Okay, the compiler cannot know for sure whether the arrays are properly aligned or not. The loop can be vectorized, but the code will be less efficient because the compiler has to take precautions to account for unaligned arrays. There are various things that you can make the code efficient. If the Intel compiler is used, use this. Declare the function inline. This may enable. What do you mean may? So compilers also behave like LLMs. Is that the question? They may or may not do something under some specified conditions. Do you know what? I may need to study compilers. Enable the instruction set with the largest vector size if possible. The AVX and later instruction set have very few restrictions on alignment, and the resultant code will be efficient whether the arrays are aligned or not. Okay, that is fine. That is fine. The automatic vectorization works. Let me look at exactly what the restrict does. Keyword explain. Unlocks levels of scary levels of optimization. May make your code super fast. The code problem it solves, why it exists in C, C++, the compiler must assume A, B, and C might point to the same memory. Okay. So it has to be a little bit paranoid. Reload values from say avoid reordering, avoid vectorizing sometimes. It's called pointer aliasing. What restrict means, the memory it points to will not be accessed through any other pointer. Okay. Compiler thinks A might overlap B, B might overlap C. With restrict, compiler now knows this thing. Let me write it down. Touch SIMD dot cpp nvim SIMD. What happened? Include std io dot h int main. Let's have two arrays. Let's not use malloc. Can we use that? Float a 4 1.0 1.0 2.0 3.0 4.1 float B4 is equals to this itself. Uh, what we can do is float C4. Let's have 0 here. Void float A float mm, for int I is equals to 0, I less than n, I plus plus C of I is equals to A of I plus B of I. Add 2 uh, BC4. Printf, what is it? CI. CD programming SIMD ls G++ minus. How do I do it in C++? 17 maybe. Out simd.cpp and okay. Why was it very slow? It is fast. Hmm. Now what you are saying is do this. I don't know why, but it looks snappy. It looked fast. Obviously, I will have to measure the time. Okay, let's go back. Declare the function inline. Where were we? Yeah. It works best if the following condition is satisfied. Using a compiler with good support. Um, who made G++? It is part of GCC project. GCC was developed by Richard Stallman, part of GNA project. Look at the question that it wants me to ask next. Next, why G++ is called G++, not GCC++. GCC++. Nice. Using the latest version of the compiler, can I do this? 13.3. 13.3. What is my G++ releases? GCC releases. We are at 15.2. I was a year old. If the arrays of structure are accessed through pointers or references, then tell the compiler that pointer do not alias. If appropriate, use uh, this or this. What is the difference between those two? I don't know. Is there a difference in these two? They both mean the same thing. Compiler and value compilers like preserve names. Is the this is style a short alias? What? Shut up. Use appropriate compiler options to enable the desired instruction set. MAVX 512 float for Linux. So you are saying I can do, what was it? MAVX2. MAVX2. Will it work? It worked. It worked. Will 512 work? What happened? Somehow not be able to, yeah. 512. 512F. That also worked. I'm not sure if I have 512 or not. Clear. Use less restrictive floating point options for GNU. Homemade clang. Okay. Use the options. Use the options. Whatever that is. Fast math. I can use fast math. F fast math. Um, F fast math. Okay. Align arrays and big structures by 16 for SSE2. So let's try one experiment. Let's try one little experiment. 100,000. N. What else? What is the issue here? It is fine. Yeah, we will remove this. So, float a n, b n, c n. For int I is equals to 0, I less than n, I plus plus, a I is equals to I, b I is equals to I plus 1. Not doing this, not required. 2. Segment what? See, a little program like this got me segmentation fault. Now I don't even know what caused it. What the hell am I doing wrong? Okay, did I initialize the arrays wrong? Printf C2. What dated system printf was not declared in this scope? Include CS. Okay. Is it because I'm using all this nonsense? Nice, 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 nice. So what I'm gonna do now is raise it to 1 million. Segmentation fault. 1 million. I need to know why setting it to 1 million is causing a seg fault. Why setting n to 1 million is causing seg fault? I'm blowing the stack. The line is the culprit. When n is this, each float is 4 bytes, each array is 4 MB, 3 arrays is 12 MB. These are local variables, so they are allocated on stack. So a typical stack size is 8 MB. So the moment main starts, the program tries to reserve on stack, which is stack overflow, seg fault. Whether seg fault happens immediately before or even after the main executes is not the issue. Okay, allocate on heap, make them static, run unlimit, ulimit stack. What is my stack limit? 8192 is 8 MB. What, um, how large can I make the heap? Entire system? Nice, unlimited. So the global RAM problem is solved. I don't know, global memory shortage is solved. Just hook everything to my computer. Now, what I wanted to check is what will happen if I remove this thing. And here it is still okay. And here I'll remove all these things. Oh, it is still fast. And if I remove this, okay, add one more zero. How is this code instant? Is there a lot of dead code in it? For shock, it is a billion. So run it with no optimizations, you were saying. It is still fast. Volatile float. Compiler cannot remove the loop. All memory must be touched. Reality hits. Let's check it out. It is still instant. This is still instant. I'm not sure what is happening here. And the real reason sync is never initialized. Why volatile does not save. Oh, I am such a big idiot. Okay, now it is taking a lot of time, and I think I crashed my system. How big of an idiot I had to be for this. Thank God, got killed. Please go back to normal. Um, let's only do a million first. Okay, now I need to do it with O2 MAVX2 F fast math. It was instant compared to what I had here. To be honest, both of them feel like same to me right now. You may look at the assembly output listing to see if the code is indeed vectorized. See page 89. Compiler may fail to vectorize the code or make the look code unnecessarily complicated. So if I do this, fine. Um, Compiler cannot rule out the data pointers are overlapping. Compiler cannot rule out. Compiler cannot rule out the branches. Compiler does not know whether the size of an array is multiple of the vector size. Size of the array is multiple of the vector size. Compiler does not know whether data structures are properly aligned. There needs to be a range to fit into vectors. The code is too complex. What do you mean the code is too complex? What defines the complexity level of a code? Don't tell me it's lines of code. The code calls external functions that are not available in vector versions. The code uses lookup tables. Fine. Compiler can also use vector operations if there is no loop, if the same operation is performed on sequence of consecutive variables. structure of four floats. We are aligning it. A structure of four floats. I understand that align as is working as intended, but I need to understand how it works. Can you explain how align as works here? In real use of virtual memory addresses to explain. Floats are of 4 bytes. Four floats is 16 bytes total. Align as every S1 object must start in an address that is a multiple of 16. Okay. What alignment actually means? Where am I allowed to start at the memory? So valid addresses look like. So this is typical alignment on most platforms is 4 byte structure, वगैरह वगैरह. That was my Hindi coming out. Suppose the compiler places S1 at base address this. This is legal. Layout will be this. Total size 16 bytes. Starting with a line as the compiler must ensure that address of S1. They like the data line to this. Okay, got it. Compiler is not always able to predict whether vectorization will be advantageous or not. The compiler may have a pragma directive that can be used for telling the compiler which loops to vectorize. Explain pragma. It is an instruction tells the compiler okay, now enter pragma pack 1. This tells the compiler ignore the alignment rules, pack everything as tightly as possible. Okay, got it. Why is this dangerous? What are other pragma directives? I remember there is something called pragma GCC unroll 4. Try to loop this unroll this loop by 4. Compiler does that. I got it. Um, Forceful unrolling, unroll 16. OpenMP, the most famous one. OMP parallel for. This one is the most commonly seen. I guess I have seen it many times. Explain this. It tries to glaze me super hard. What OMP parallel really means, a single line does two things at once, creates a team of threads, splits the loop iterations among them, threads across the core, I assume. Suppose you have four course, OpenMP will create 4 threads. So, okay, something like this. What exactly is OpenMP? Multi-platform shared memory parallel programming in C, C++, and Fortran. But there's a huge rule. Each loop iteration must be independent. There's a race condition. Okay, multiple threads write to some. Result is garbage. Fixing races, you do reduction for some. Hmm. Getting a bit of getting a bit of it slowly. Fix it with atomic race condition. So we do atomic. Okay, got it. So what you are saying is I can I'll first of all remove this too. Here I can do pragma loop unroll. No, sorry. What was it? Yeah, this one. Pragma OMP parallel for. So do I need to give out a flag for this? Will this work? Is there a flag called fopenmp? Fopenmp. There's a flag for it. Nice. We started a lot to go. There's a lot left there. Okay, now where were we? Yes. Apologies. The complication is the code contains branches. Where are the branches? These are the branches. The way to handle branches is to calculate the both sides of branch and then merge the two result vectors so that some vector elements are taken from one. Okay. Compiler will not vectorize the code in this case if there is a theoretical possibility that a not taken branch will generate a trap for an exception, such as a floating point overflow. You can help the compiler to vectorize the code by specifying the compiler options. It is not recommended to use the option because it will disable the detection of infinity in NAND. Use the smallest data size that fits the application. For example, you can double the speed by using short int instead of int. Short int int is what? 16 instead of 32. 2 bytes. You can have 8 numbers of type short int in vector while you can only have 4. Therefore, it is advantageous to use the smallest integer size that is big enough to hold the numbers in question without generating the overflow. Likewise, it is advantageous to use float rather than double if the code can be vectorized. The SSE2 cannot multiply integers of any size other than shortened. I don't give a damn about SSE2. How many times I have to say? Using intrinsic functions, it is difficult to predict whether the compiler will vectorize a loop or not. The following example shows a code that may or may not vectorize automatically. The code has a branch that chooses between two expressions for every element. Shortened A, shortened B, shortened C, I less than this. If B is greater than 0, then do CCI plus 2, otherwise multiply both them. If B is negative, got it. Impossible to vectorize code explicitly by using the so-called intrinsic functions. This is useful in intrinsic functions are somewhat similar to assembly programming in the sense that most intrinsic function calls are translated to specific machine instructions. To be honest, a lot of it is going above my head sometimes. Intrinsic functions, what are intrinsic functions? Half language, half hardware concepts. Compiler provided functions that map directly to CPU instructions. Oh, okay. These are intrinsic that they were talking about earlier. Yeah, I know that. Compiler may be able to optimize the code further by reordering instructions. We want to vectorize the loop in example 12.4a so that it can handle it can handle what can it handle? 8 elements at a time instead of 16 billion digits. Branch inside the loop can be implemented in various ways depending on the available instruction set. The traditional way is to make a bit mask with all the ones when BB is 0 and when this is false. The value of CCI2 is ANDed with the mask and with the intrinsic mask. The expression that is ANDed with all the ones is unchanged, as all zeros give zeros, and the or combination of these two gives the chosen expression. Okay. Function to load unaligned vector, integer vector from array, static inline, load vector, uh, short integer 128, load and store. We have a 0, we have a vector of 2's, I opened LinkedIn by mistake and I can't say anything more. Make a vector of this, make a vector of this, roll out the loop by 8 to fit the 8 elements into the vector. The code looks horrible to be honest. I mean, just by looking at the aesthetics of it. The resulting code will be more efficient because it handles this. The type defines 128-bit vector containing 8 integers, blah blah blah. The corresponding vector registers are called, okay. There are thousands of different intrinsic functions that may be difficult to find the right function for a particular function. The AND or construction in example can be replaced by a blend instruction if this is available. This thing, what are they talking about? The AVF instruction provides an even more efficient way of branching using a mask register and conditional instruction. What happens per 16-bit element? Uh, Change the code to use floats instead of um, shortends and give me the main function. Vector type is an integer vector, holds whatever the hell is this, 32 lanes of 16-bit integer. MM512 set 0 shortened. SI I am assuming is shortened, right? It creates a 512-bit vector where all bits are 0. Hmm. Okay. Broadcast a single 16-bit value to all the lanes. Okay. Operates on 16-bit integers. Loop unrolling by 32. For each iteration, process 32 elements, load 32 elements, got it. Y unaligned, safe even if isn't executable, slightly slower than line node, flexible. Multiplies each pair of the lane, keeps the lower 16 bits of the result. True result, stored result is. I'm getting it a bit, but initializing the input, select add multiplication, so on. Vector of all zeros, vector of all twos. Explain all intrinsic functions. No, I don't have 512 set, right? I only have 2 to 6. CPU. Let's create void select float AA, uh, float BB, float CC, and here M256. What is it called? M256, right? MM256 set 0 PS. Use of undeclared identifier. Why is it undeclared? Okay, so functions are with M 256, we will say 256 set 1. How how are these functions named? Set 1 PS 2.0 F. Set 1 set 0. And we will process 8 floats per iteration. Why 8? 256 by 8 is 32. The float is 32 bit. For int I is equals to 0, I less than 256. 8 elements at once, right? We'll load B and load C. Okay, we'll load B and we will load C. So let's first load them. M256 AA, sorry, B is equals to M256 load U. What is the PS? BB plus I. Will the compiler tell me anything? Load U PS. M256C it loads 128 floating point vectors. Now this side needs this. Loads 8 single precision. Multiply these together. I will multiply, but before that, what are is a way to store decimal numbers in computer using 32 bits. Oh, so it is just a confusing name, nothing else, right? M256 on the multiplication of B M256 mul 256 multiply what is this? Multiply PS EC. Okay, so this is multiplying B and C. Compare the mask. Compare the mask. Compare greater than Let me just search the full form for it. What is this? I know it is compare greater than what is OQ. Is a comparison constant used by this ordered and quiet per element. Comparison is false if either operand is not available. And NAND. No floating point exception is raised. Hmm. We can also multiply, let's say, both of them together right now. C2 is equals to M256 add PS. Do we have anything called add? C and 2, right? This should work. What will this return? See, a lot of help is being taken from ChatGPT because why not? It returns a vector mask, not Boolean. Return type is to 32-bit floats. So it looks like 0 1 0 1 0. M256 mask M256 compare. Is there anything called compare? Why don't I have half the functions coming up in this LSP? Compare. So what we need to compare is um need to compare B with 0, compare G. This should be right, right? Then we have something called result, which will come from M256 blend. Blend has to be taken from BC, C2 and mask. And we will have something called store, PS, this thing, which should store R. Hmm. Okay, okay, I'm getting a sense of it. I am getting a hang of it. It is a very tiring process to learn all this stuff. You have to make sure the CPU supports the instruction set. Program will crash if does not support it. All compilers except Microsoft. Loading data into the vector goes faster if the data are aligned to an address divisible by vector. This has significant effect on older processors. Align as 16. So how did we use multiple cursor in NeoVim? I forgot. I actually forgot. Um, that worked somehow. So can I print? Can I do this? I mean, 16 times 0 plus 2 times 1 2 times 16, obviously. In decimal is 32. So and this is not divisible because it is 16 in binary. Lookup tables can be useful for optimizing code, as explained on 144. Unfortunately, a vector of this provides the indexes into table into memory. It is tedious. Yes, it is tedious. It is possible to write the same in a clear and intelligent way by wrapping vectors into C++ classes and using overload operators for adding things like vectors. The operators are in line so that the resulting machine code becomes the same. Got it. So the advantages of vector classes. Specify. So the code is this. Various libraries of predefined vector classes are available. Uh, okay. Version 2, vector class. We will look at it later on. They want me to make a custom class for this, right? It is not recommended to use vectors of 64-bit total size because then you have to be incompatible with floating point code. If you do use execute mmmt and so on, the following shows Intel vector class. Uh, okay. Okay. Why can't I use macros for this? Same thing using VC class looks like. B dot load, C dot load, A dot select. What the hell is all this? I'll quickly read this. Maybe I'll read it tomorrow, but I like the idea of making a vector class for all these operations. Preprocessing uses their own library and not interested in it. Transforming serial code for vectorization. The above trick is serial because the sum uses. Okay. The code can be vectorized using the vector class library. The mathematical function for vectors. Various function libraries for computing mathematical functions, such as logs and so on. There are different kinds of vector math libraries: long vector math, short vector math, Intel vector math, IPV. Yep, open source. What is this? using short vector math libraries with different compilers. How do languages like Python use these um, intrinsic functions? Can we use SIMD there? Hmm. So it happens in the backend. Modern Python ML frameworks, they use SIMD, fast FMA's fast math, used multiply addition. Okay. Okay. Let me do one thing. I'll create my, let's start creating my own vector class. Type def struct v um I'll only support float for now. Float data size capacity. Size t size current capacity. What is happening? To create uh struct, first this is just here to now it there we have our data, we have uh, uh size, we have capacity. Now okay, let me think, how do I want to do this? We get vector, you will require an array of data, you will require size, and you will require capacity. um Malloc size of v. What is wrong here? Oh, non-void function. If um result, okay, now we are not creating dynamic size. Okay, so float, no. Result dot data is equals to float malloc size times size of if result dot data you know what, let me use it here too. For size t I equals to 0, I less than size, I will use free to free v. um Result data I equals data I and result dot size, that will be equal to size. Okay, that should give me uh, a get. There should be something to free that to void. Okay, Um, Apologies. Give me 2 minutes. I'll have water break. Okay, let's start back. For now, it should work. It's working. What I want is to have operator overloading here. How do I create operator? Let me ask there. How to do operator overloading of plus for a struct in CPP? When you write APSP for a struct, okay, struct this operator plus we take a constant vector A, constant vector B, return this. Hmm. Okay, how do we want to do this? So, okay, for and um, I less than size. First of all, if uh, size is not equals to, if size is not equal to, can we do this? Operator must not return a reference, creates a new value. You cannot safely return a reference unless you return an existing object. Um, what is the best way to do this? Uh, Size do not match. Okay, so it must be non-void return this. No, I don't want it. How to make it work? Hmm. Constant vec A, constant vec B. we create a new thing called C. C dot size is A dot size. Get vector. Okay. We have the vector. We have okay. So now what can we do? For and I equals to 0, I less than, how was it working? I less than 256, not 256. I less than, let's do C dot size. And we will load the 256, so 32. It will be 8, right? So M M256A will be equals to MM256 load UPS. We will load A dot uh, what is the error? Is not a structure. Member reference base type is not a structure. Okay, we have now added two of them together. Now let's create a result. Uh, MM add PS, and add PS will be MM256 load UPS, not load. We will do store. What was the thing for store? Okay, what we need to do is Can still a type? Wait a second. So maybe this is not required. Unknown declared identifier CC. So what exactly is the issue here? Cannot convert V to float. C dot data. Okay, this seems to work. VV2 is what the hell is this other? Hmm. So I don't want to spend a lot of time here. What else? Okay, this looks much better. Hmm. Let me do one thing. No, earlier one was better. Looks fine, looks fine, looks very fine. What else? Um, what else do we need to do? Fine, this is done. Let me clear one thing. Why do I need CPP 3 out of 5 rule? I am keeping it as close to C as possible, only using CPP for operator overloading. because C++ copies your struct. This would be impossible. This line forces object copying whether you want it or not. You're not choosing the languages. What is happening versus what's actually happening. C++ asserts hidden copies at these points. It expands to, okay, copy constructor does this by default. Okay, whatever. For now, it is working. At least I'm not putting it any. I was just experimenting. If it, what will it look like if I try to do operator overloading for this thing? Turned out to be nice. I guess I'll continue this thing later on. Stopping the recording right now. Thank you.